Have you ever stopped to wonder how much energy your body burns when you're just sitting there, totally couch potatoed? Or did you know that right now, at this very moment while you're watching Icarus, your body is using several times more energy than a glowing light bulb? And what does watt even mean anyway? When someone says a device uses 200 watts, what are they actually talking about? Today, we're diving into the world of power, watts, horsepower, and those colorful energy labels. But don't worry, we're not doing dry formulas or textbook snooze fests. We're going to use simple language and fun examples to understand how energy works, how to slash your electricity bill, and how to save the planet in the process. Here's what's on the menu today. Where did watts and power come from? How do we measure work and the difference between power and energy? Horsepower, the ultimate marketing trick. Don't let salespeople fool you with big numbers. We don't like throwing money away, so what exactly is efficiency? What are those energy labels actually telling us? First things first, what is power? Power is simply the speed at which energy is consumed or produced. Watts are the units we use to measure that speed. 1 watt means that every single second, 1 joule of energy is being transferred. Think of a joule as a tiny bit of energy, the loose change of the energy world. So when we say a device is 100 watts, it means it's gobbling up 100 joules of energy every second. This number tells us exactly how much energy the device needs at any given moment to stay alive. Here's a fun fact. The human body, while just sitting and resting, uses about 100 watts of power. That's right, you're basically a living, breathing 100-watt light bulb. If power is the speed of consumption, energy is the ability to do work. We measure energy in joules. But how much is 1 joule exactly? Physicists decided that 1 joule of energy is required to do a specific tiny bit of work, lifting a 1 kilogram weight exactly 1 meter high. So if you pick up a 1 kilogram weight from the floor and lift it 1 meter, congratulations, you just did 1 joule of work. You can take a break now. I have a feeling that starting tomorrow, some kids and husbands are going to start reporting their household chores in joules just to make it sound more impressive to their moms and wives. Back to the science. 1 watt is 1 joule of energy used per second. If you lift that 1 kilogram weight 1 meter in exactly 1 second, you've exerted 1 watt of power. But if you take 2 seconds to do the same job, you've only exerted half a watt. See? When it comes to power, it's not just about how much energy you used, but how fast you used it. For example, if 100-watt bulb stays on for an hour, the total energy used is 100 watt-hours, or 360,000 joules, because there are 3,600 seconds in an hour. You can see the math on the screen. By the way, notice I said consuming or producing. That's because energy doesn't just vanish. If it's consumed somewhere, it was produced somewhere else, like electricity or cooling. So both the things that use energy, like your TV, and the things that make it, like a generator, have a power rating. If you're into cars, you've definitely heard the term horsepower. But did you know horsepower is also just a unit of power? 1 horsepower is roughly equal to 746 watts. The idea was cooked up in the 18th century by James Watt, the Scottish engineer who brought the steam engine to the industrial world. When he wanted to sell his steam engines, he needed a way to compare them to something people actually understood. And what did people use back then? Horses. He needed to show mine owners and farmers exactly how many horses his machine could replace. But how much work does a horse actually do? Watt went out and watched. He observed that a typical pit pony in a mine could pull a 180-kilogram load up a 30-meter shaft in about 1 minute. That became the official definition of 1 horsepower. In simple terms, he told his customers, "My engine has 10 horsepower, which means it does the work of 10 real horses." It was brilliant marketing. The guy was basically the Steve Jobs of the 1700s. But don't get any ideas about your own horse. Real horses can only exert 1 horsepower for a very short burst. It's exhausting for them. Mr. James Watt forgot to mention that part to his customers. And in case you haven't guessed, physicists named the unit watt in his honor. So horsepower and watts are essentially the same thing, the speed of doing work. One is just inspired by real horses. If your car has 100 HP, it means it can consume or produce 74,600 joules of energy every second. 100 HP times 746 watts equals 74,600 watts.
Imagine 2 people climbing the stairs at the same speed. They both climb 5 floors. Person A uses 100 watts, but person B uses 200 watts. They did the exact same work, but person B used twice the energy. Some people are like 4-wheel drive SUVs. They just waste energy for no reason. This means person B is less efficient. Maybe they weigh more, so it takes more energy to move them. This is like 2 cars driving the same distance in 1 minute, but the second car burns twice as much gas. The lesson? A higher wattage doesn't always mean more work. It often just means more energy wasted. So is lower wattage always better? Not necessarily. If 2 machines do the exact same job, the one with lower wattage is better. But what if they do different jobs? If you have a car, 1,000 watts, and a truck, 5,000 watts, and you need to move a massive load of bricks, you aren't going to buy the car just because it has lower wattage. It simply can't do the job. Keep these 2 points in mind. 1. High power doesn't always mean high performance. It might just mean it's a gas guzzler. 2. Make sure the device actually fits the task. Lower power might just mean it's too weak for what you need. Next time a smooth-talking salesperson tries to hype you up with input power or output power, think of the car versus the truck. Don't let them trick you into buying something that will just help the electric company milk your wallet every month. Let's look at 2 real-world examples. The hairdryer trap. A seller says, "This dryer is amazing. It only uses 500 watts, way less than that other one. But if you have long hair, that 500W dryer won't have the oomph to actually dry it. You'll be there all day." The iron trap. A seller says, "This iron is a beast, 4,000 watts, way better than that 2,000 watt one. But if both irons do the exact same job of smoothing your shirt, you're just paying double the electricity for the same result." If this feels complicated, don't worry. I promised to keep it simple, and there is an easier way to protect your wallet. Efficiency is the ratio of useful work to total energy consumed. Simply put, how much of that energy actually went into the job and how much was wasted. If a device pulls 100 watts of energy, but only does 80 watts of actual work, its efficiency is 80%. Simple, right? I promise scientists don't use these big words just to confuse us, though I can't say the same for high school physics textbook authors. Where does the lost energy go? Usually, it turns into heat or vibration. Efficiency is huge because we don't want to throw money away. Unless you have a secret crypto mining farm and free electricity, you probably care about your bill. If your device has low efficiency, it's like paying for a full gallon of water while your pipes are leaking half of it into the ground. If you have questions about this, just ask any dad when he sees the AC running with the window open. He'll explain it perfectly.
How do you check efficiency without a lap? Look at the energy label. Most electronics have a sticker that tells you how much energy they use and how efficient they are. These are usually color-coded from green to red. Green, low consumption, high efficiency. The good guys. Red, high consumption, low efficiency. The energy hogs. These labels show annual energy use, noise levels, and sometimes water usage. In the US, we have Energy Star. Only the best performers get this badge. In the EU and Asia, you'll see the A++ to G scale. A is the gold standard. G is, well, try to avoid G. If you want to be a smart consumer, 1. Remember that watts and power represent the speed of energy use. 2. Keep an eye on efficiency. 3. Take those energy labels seriously. If you're looking for a machine or a car that turns the most energy into actual results while keeping your bills low, look for high-efficiency brands. Remember, we are all living light bulbs. Let's make sure we're using our energy wisely. Our world is full of amazing and sometimes incredible stories. If you found this video interesting, please like it and share it with your friends. Be sure to write your comments and questions in the comment section. We'd love to know which part of this story was most interesting or surprising to you. Stay curious until the next video.